Hello, hello, there we go, okay. Okay, I hope your break was good. And we're going to continue with our next presentations here. So please have a seat. And, sorry, hold on. Okay. Okay. Okay, have a seat. We're going to continue here. And we have our next presenter is going to be Dr. Ben Clausen on a very important topic. He, of course, has spoken a couple times before. And he has given us some very good insights on many things. And as before we mentioned, that he has been working with the Geoscience Research Institute for about 35 years. And he has been working in many countries. And I was also interested, actually, this is one topic I was very interested in because he's talking about geometric dating and things like that, and time issues. And a lot of people, when we try to witness for the faith of God and the truth, they're going to come back with us and say, hey, the world is millions of years old. How can the Bible be true? And I know some real people who like that. And also I know a couple people in our church who said, if that's not true about the age of the earth, then why should I be a Christian? And so I asked him to speak about this and talk about issues there. And he said he also had a hard rock group. And that's a very interesting one. At first I thought, oh, Hard Rock Group, maybe they go to the Hard Rock Cafe for their to eat. But it's also good because I have a group called Rock Solid Faith. So, and who is the rock? Jesus is the ultimate rock and foundation. And so I'm sure we'll learn about real rocks and also Jesus the rock. And welcome, Ben Clausen, Dr. Ben Clausen.
So I'm going to tell you about my favorite group of people here. I am very proud of the group of students and fellow collaborators that are looking at geology. They've kind of divided geology into soft rock and hard rock. And soft rock is sedimentary rock. It's a little bit softer, and it's mainly laid down by water. Hard rock is igneous rock, like granitic rock and volcanic rock, and also metamorphic rock, and it's usually harder, and it kind of fits in a different category. So that's what we're talking about, is hard rock. We study granitic rocks and volcanoes and things like that. And so these are the very illustrious people that I work with. Dr. Martinez is a professor in geology at Loma Linda University. She was my student for about 6 years, and then went and did a 3-year postdoc, and now she's a professor. And I'm extremely proud of the things she's doing there, working in Peru and other places. The next one is Lance Pompey. He has a background in computer science, worked in computer science for a while in South Africa, taught English as a second language in Korea, and then came to Loma Linda. He teaches GIS, various computer classes at Loma Linda, but he just successfully defended his PhD dissertation a week or two ago, and he will soon be doing a postdoc there at Loma Linda. This is Alex Voos. He is a theology and geology graduate. He has a bachelor's degree in both, theology in Brazil and geology in Austria, but now he's working on his PhD with some research in Peru, but he's at Loma Linda University. Next is Dan O'Hare. We're working with him on research in Hawaii, looking at the volcanic rocks there that occur rather rapidly in all volcanoes. Maria Roman is from Peru. She's looking at environmental issues. Mateo Ospino is from Colombia. He also spent some time in Argentina. He is looking at a granitic outcrop within about 5 miles of Loma Linda University. So he's doing something very local. Luis Pereira is from Brazil, and he is looking at some granitic rocks in Peru that we've looked at before, but he's looking at hydrothermal alteration, hot water. So what can hot water do? And Raquel Bendita is also from Peru. She just successfully defended her master's in geology, looking at the granitic rocks in the foothills of the Andes, right around where she grew up and where she attended the Adventist University there. So these are some of the people that I'm very pleased to be working with. I'm very proud of these people. So this is probably too small to read, but I'm going to go over this, and this is kind of the summary of what I'd like to tell you about. We're not going to get to all of this, but it'll give you an outline of the things that we could talk about. So the issue is, how do you understand the relationship between the Bible record and the geologic data? What it says in the first few chapters of Genesis and what it says when you look at the rock record. So we are looking at rates. How fast do things happen? How fast does plate tectonics happen? How fast does heat flow? How fast do you get radioactive decay? And the Genesis record seems to indicate some worldwide geological effects. So we consider it important to look at geology worldwide, not just locally, but worldwide, both in space and time. So horizontally, we're looking at plate tectonics, the continents as they move around. How fast can they move around? What happens when they move? What are the results as you look at the granites and the volcanoes that come from that? So we're working on that in Peru, Mexico, Chile, and Colombia. In the middle of these plates, you also have some volcanic or magmatic activity. So in the middle of them, you have Hawaii, Galapagos, other places in the Atlantic Ocean like Iceland and so forth. So we're looking at a couple of those places. Large data analysis that you just heard about from Dr. Alferez. And we're very pleased to be working on him. If we're looking at worldwide effects, we need to be looking at lots and lots of data. So we need to do large data analysis. We're also looking vertically at the geologic column. There's a sequence of events. Sometimes there's quite a complex sequence of events. How do we understand that? And in that area, we're looking especially at granites and volcanoes and various magma chamber processes, heat flow, water effects. The Genesis record seems to talk about lots and lots of water, a big flood. So we're looking a lot at water effects and how does that help us understand the geologic record. And finally, time issues, radiogenic isotopes. People always, the first question they ask is, what do you think about radiometric dating? Is this the biggest issue for a short time frame? And we're spending a lot of time trying to understand how radiometric dating works. We've worked in labs, the different methods and so forth, trying to understand what are the different ways you can understand these isotope ratios that are related to radiometric age. We're especially looking at uranium lead, but we're also looking at some of the others, rubidium strontium and argon argon. So I'll talk a little bit about this. Quickly, I'll go through some of the field work, the type of field work we do, the analysis, the reports, and so forth. I'd like to emphasize that Jesus said we're to love God with all the heart and soul, but also with all the mind. So we need to be using our minds as part of loving God. And I'd emphasize the respect for God's world, and people in his image. And I wrote a short chapter in a book a couple years ago about how I relate to these kind of issues. So we'll talk briefly about this. Looking at the history, doing good science, making sure it's large scale, theodicy issues, understanding our own human limitations, and treating people well. The resulting lectures are to point to a creator who is a good and powerful Christ-like God. So, how is the Bible record and geology related? This is a diagram from Leonard Brand's book, Faith, Reason, and Earth History, where he talks about the science domain, the religion domain. You study each. It's kind of a cycle of events. You study, try to interpret, and you relate the Bible and the natural world as you do that. So you expect harmony between the two. As Ellen White says, the book of nature and Revelation speak in harmony. So that's what we're looking for. At this point, we don't have a working young Earth creation scientific model to understand plate tectonics, the geologic column, or radiometric dating. And there are lots of people working on this, and it would be interesting to see what kind of models are possible in relating what we see in the natural world and what we see in the book of Genesis. So, first of all, a little bit about plate tectonics. Plate tectonics is where you have the continents consist of the plates. You also have the Pacific plate that's an oceanic plate. And then you have lots of little plates. And so these pieces of land or these pieces of oceanic crust move around. And there's three ways they can move. They can move together, or they can move apart, or they can move past each other. When they move together, you have a subduction zone like this. This is what we have off of South America. The Pacific plate or the Nazca plate is moving underneath the South American plate. And as a result, there's water that's being subducted, and the water lowers the melting point. So you have the rock turned into liquid, to magma. If it comes up to the surface, you have volcanoes. If it doesn't get that far, it cools underground as granite. So that's the kind of thing we're studying. In our case, it's in South America, off of Peru. But also we've looked at some off of Chile, as well as off of Colombia. So our big area is in Peru. In 2018, we had a field conference for several weeks that went from the Amazon into the Altiplano, then over to the Pacific coast. And Dr. Alferez spent a week or two on that conference. So we're looking at a number of areas there. These are some of the things that we had published. This particular one is with Dr. Alferez, looking at large data analysis of rocks in California, but we've also done some work in Peru and some other places as well. Looking at the geologic column. And so you have Precambrian, some people suggest that's pre-flood, Paleozoic, in some models that would be early flood, Mesozoic, in some models that would be late flood, and Cenozoic, and that would be post-flood. So we're especially looking at this part of Peru that includes Cuzco, Machu Picchu area, a little bit in the Amazon, but especially along the coast and Lima and south to Pisco and Nazca and so forth. So Machu Picchu is one area we're looking at. We've collected some rock samples, not in the Machu Picchu area, but a couple kilometers away, and done some radiometric dating on those. Down close to the coast, we look at one area where it appears that magmatic rock, granitic rock, got intruded into volcanic rock, and we're especially interested in what happens at the contact between those. Some quite spectacular places. This one is Nevado Azangate, 6,300 meters high. That's about 21,000 feet, something like that. Pretty spectacular. Some of our colleagues are looking at whales in the area very close to where we're looking at the granites. These are very well preserved, and they suggest that they were deposited very rapidly. Also volcanic activity. Granitic activity is usually considered to be very slow, whereas volcanic activity, you usually think of it as being rather catastrophic. So how is the catastrophic rapid activity related to what appears to be slower activity when you're looking at granitic activity? So this is in southern Peru in the Arequipa area. And they have earthquakes there. It's a subduction zone, so they regularly have earthquakes that can be quite destructive in the area where we're working. So the Pisco area, here's Lima there, here's the Pisco area here. They had quite a major earthquake back in 2007. So this is one student, Lance Pompey, put this one together, looking at flare-ups. Why is it that some of the time you get lots of magmatic activity and other times you don't? And this is what he put together in his PhD dissertation. He just defended it, so now I can call him Dr. Pompey. And he is looking at why do you get lots of magmatic activity at some times and not at others. We're also looking at water effects. That's what you'd expect from the Genesis record, that you might have major water effects and in fact hot water. So it's called hydrothermal for being hot water. So this student, Luciano Gonzalez, was looking at the effects of hot water, alteration of the rocks, and he got a paper published in the Peruvian Bulletin of the Geological Society of Peru. And he was looking at some of these hot water effects. Here you can see we went down in a mine about 100 meters deep on these rickety ladders and took pictures as we went down. This was a copper mine, and you can see the copper ore there. And so this is generally considered to be the result of hydrothermal alteration, hot water moving through the cracks in the rock and depositing copper ore. Okay, the next one is, how do we look at time issues? How do we understand them? The people at University of Arizona in their radiometric dating lab have been very good to work with. We've gone there about a dozen times. They're always very gracious. They're anxious to have us come back and continue working with them. Most recently, we went there in February and spent an entire week at the lab with several of our students, as well as Dr. Martinez and Dr. Pompey, and also the director of the Institute, Dr. Naleen, looking at samples from Peru, from Utah, a little bit from Hawaii, from Tanzania, and so forth. The first time we went there was in 2014. And before we went, I put together a series of thoughts about how does one go about understanding these time issues with relation to the Bible. So there's a lot that can be said about that. I'm not specifically giving a talk on radiometric dating here, but there's an awful lot that can be said about understanding the radiometric dating data. We have set up a lab at Loma Linda University for separating zircons. So we will take a sample of granitic rock, crush it down so it's sand size or maybe small sand size, and then we'll separate the different minerals that are in there. And so we separate out these little minerals called zircons. Now, normally the little grains are often quartz grains, but occasionally some of them are zircon grains instead. And so those are the ones that we use to look for radiometric dating. So here we crush them with this machine. We use a magnet to magnetically separate some of them. This is the lab. We use heavy liquids. And so these heavy liquids have a density of about 2, a little bit more than 2, about twice as much as water, or 3 times as much as water, sorry. And so your sand grains will float, whereas the zircon grains will sink. And so you're able to separate them that way. And here's some of the resulting zircon grains that you get. We've published a couple papers on the radiometric ages. Here's one of them that Dr. Martinez published. It was a result of her dissertation. This is a zircon grain. It's about 1/10 of a millimeter across, 100 microns. And these are the kind of ages that we get from it. This is one of the figures from this particular paper, looking at radiometric dating and trying to understand it. Another paper that Dr. Martinez published as a result of her postdoc, trying to understand these isotope ratios. And how can one explain these isotope ratios? There's many ways of getting these isotope ratios, and we're trying to think of various interpretations for how you can get that. So a little bit about the field and lab work that we're doing. What are some of the rock types? What kind of work areas do we work in? We take students both from the United States as well as from the Adventist University in Peru to look at some of these areas and what kind of lab analysis do we do. So when we collect the rocks, we put them in these cloth bags and label them and bringing them back to the United States in these suitcases. So sometimes they wonder, what are you taking there? And so we say rocks, and it seems to be fine. So we bring about 50 pounds of rocks per suitcase back to the United States for various geochemical analysis. So some of our work areas. I already showed you this picture where it appears that magma is intruded into volcanic rocks. This is what the area looks like down there. It's not very pretty, but geologists love it because you can actually see the rocks and instead of just seeing all the biology that sits on top of the rocks. This is one of the mines that we visited. You can see the copper ore here. The people were kind enough to let us go down in the mine. Probably it was rather dangerous. They're pretty rickety ladders, but we'd go down like 5 meters on one ladder, and then there'd be a landing, and we'd move over and go another 5 meters down, and so forth. And this is Dr. Pompey here with the miner's hat and so forth. They let us go in there looking at these copper porphyry deposits. So here you can see what it looks like. Some of the ladders here. Dr. Gonzalez, Luciana Gonzalez, you can see the ladders going down to the landing and so forth. This one we were looking at hydrothermal alteration, hot waters that would move up from the granitic intrusion into the volcanic rock and alter the rock and deposit copper ore there. This one was in 2019. We visited this same area, and now we have a drone. We fly around, so it makes it so we get nice little videos of these areas, and we're able to look at places with the drone that we can't actually access on some of the cliffs and so forth. So this was our group in 2019. Maria Roman, I already told you about. Orlando Poma teaches at the Adventist University in Peru, and he is an invaluable asset in accessing various areas there in Peru that might be difficult to access otherwise. Dr. Martinez, Alex Voos, and this is my wife. She actually came along with us in 2019, and I have a fabulous picture of her knitting on a rock out in the middle of nowhere. So this is what her husband makes her do, go on trips and end up knitting out in the middle of nowhere. This is one of the students, Alex Voos, is making a geologic map of this area that we're studying. We'll be going back down there in June for several weeks to look at this area in more detail. Some of the examples, a GPS to get locations so we know exactly where we collect the rocks. Some of the altered minerals that you can look at here in one of the granitic rocks that we collected. So this was 4 years ago, and we had several students from UPU, the Adventist University there, with us. And each of them was supposed to make a report about what they saw in the field. So this is the report of one of the students, Carlos Zafra. Let me see how I'm doing for time here. 14 minutes. 14 minutes, okay. Keep, okay, good, thank you. Okay, here's our mineral separation. I already showed you some pictures. Grinding the zircons here, then separating them with heavy liquids. You can see the sand floats, whereas the zircons sink. And in some cases, we'll take the powder. Oops. Huh, I guess I can't go backwards. Are you able to go backwards for me? Yeah, go back a couple. Yeah, okay, that's good. Okay, that's fine. Okay, so this is where at the radiometric dating lab, oops, I'm not even touching it. I guess it wanted me to go to the end here. Okay, can you put it back? I won't even touch that. Okay, so here we go. So one of these, you zap the little zircon grains with a laser beam, and so it turns the uranium and lead atoms, it puts them into a helium stream or in an argon stream of noble gases that take it then to the second machine here, where it's run through a mass spectrometer, and separates the different ions based on their mass, the uranium and the lead and so forth. And it counts them. And once they're counted, you can get ratios. And so here you can see some of the results on a plot. Okay, the next slide. Or maybe I'll try punching. Oh, here we go. Okay, so this is one of the results. Orlando Poma, as well as Dr. Pompey at a conference, I think this one was in 2018 in Washington, D.C., looking at some of these zircons and so forth. Okay, the next slide. Okay, a year ago, I put together a poster for the general conference session telling about our research. And this is on the web. It's open on the web. If you have questions, you can email me. The web address is just bclausen.net/GC poster. And you can get a copy of the poster and a bunch of details besides just the poster. It tells about some of the people that we're working with that I've already told you about, looking at large-scale research, looking at vertically in the geologic column, as well as horizontally around the world, the projects that we're working on in a number of different ages, just a little bit about the results, the approach that we use in looking at it that I've already told you about last night, and the message that we're trying to share. Okay, next. So looking at the abundant life, and I told you about this life last night, we have a web page where I tell about what I'm doing, but what our entire research group is doing to keep people up to date on how we're understanding and studying God's world, and some comments about how it's related to our beliefs as Christians. Okay, next. I've outlined some of our ways of dealing with it in this chapter in a book that came out 2 years ago. Actually, I think was available. There were several copies available last night that were out on the table. And if you're interested, you can go to the GRI website, and I think the books are available there as well. So it's just a very short chapter. It's only about 3 pages long, but kind of describes, okay, thank you. The chapter describes our approach to looking at these issues. Okay, excellent. So the 6 parts to looking at them are: make sure we learn from history, do good science, study large-scale geology. For me, the big issue is theodicy. Why do bad things happen to good people? I'll talk some more about it this evening. But I understand that God wants to get the bad stuff over as quick as possible. And that's the reason that I'm looking at ways to understand this in a short time frame. Recognizing my limitations as a human and treating people well. Learning from history. We talked about this last night, that modern science actually developed within a Judeo-Christian culture. Doing good science. The church is anxious to have us do good science and have been incredibly supportive of that. I have some guidelines for doing the science that we need to work within the scientific community, and I'm not going to go through them all here. Looking at the big picture, we're looking at this worldwide, but we're also looking at some other areas. I come from a nuclear physics background where I was looking at trying to understand radiometric dating issues from a nuclear physics perspective, and then I switched over into geology. So general relativity, quantum mechanics, plate tectonics, catastrophic geology, and so forth. The theodicy issue that I'll be talking some more about this evening, recognizing our human limitations and treating people well. So I give my life story, and this is the kind of lectures that I end up with to talk about these things. Learning from history, Christianity aided the development of science, and the Galileo story. Doing good science, so I talk about God and the new physics, the Big Bang, design in the physical universe points to a designer, introduction to geology, plate tectonics, igneous geology and issues for Christians and ways of dealing with them, and radiometric dating in time. Other issues in large-scale geology, recognizing our human limitations and treating people well. So this is the message that we share, and I think I'm finished. So if you have some questions, I might have a couple minutes left.
Oh, yes.
I think it was back in the 1990s, there was a fairly large group of creation scientists, John Baumgartner, which you probably know, Kurt, others, were in a project called RATE. And I'm kind of wondering where that research, has that led into your research? Where have we gone from the RATE project to where you are now?
They ended up with 2 books. Volume 1, I think, was in 2000, and Volume 2 in about 2005. And in each case, they sent me a chapter from them to review. So I've reviewed 1 chapter from each of them. And I have them sitting on my bookshelf. And we look at those to get ideas from that need to be researched and so forth. So they're quite interesting. They're freely available on the web now, so you can just download them for free. But they have a lot of interesting ideas that need a lot of research. So, yeah.
I do have a question. If you maybe if someone read online, hey, the geometric tracing of rocks and trees and things like that, they show that they're older, but we're saying, you know, it came when God created these things, it came with a certain age to it. Like, how do you balance that when someone who hasn't really done the research and isn't really sure where to find the truth in that?
That's a very good question. I give a talk on radiometric dating, and I outline 8 different suggestions that creationists have for understanding radiometric ages in a short time frame. And the 8th one is when God intervenes in human affairs, you can get strange results on time perception. And so, for example, if a biochemist would have been able to study the water turn to wine at the feast at Cana, would the biochemist have been able to tell that it had just, took a very short time to turn from water to wine? Or would he have automatically thought that it had come from water, gone up into the vine, gone into the grapes ripened, and then they were crushed and so forth? So when God intervenes, maybe there's big effects. So that's not really doing science, but it is looking at some alternative understandings. Another example is, what about Joshua's long day? So God intervened there, and your time perception is kind of different there. Or I think there's another story about Aaron's rod was put into the ark one night, and the next morning there were lots of almonds on it. So you got the almonds that budded and everything in a very short time. So the possibility of looking at something and it appears older than it really is, that's one of the suggestions that creationists have made. If you had gone into the Garden of Eden on Friday afternoon of Creation Week and looked at Adam and Eve, would you have been able to tell that they're only a few hours old? Or would you have automatically thought, well, they appear to be adults, 20, 30 years old or whatever? So the appearance of age has been suggested. So, yeah. Okay.
Oh, sorry. One more, Dr. Clausen.
Yeah, tell me when I need to stop. So.
My question is kind of related, but just to radiometric dating, and I might be wrong, but my understanding was that it is kind of based on the premise that the environmental conditions were constant. But if they weren't constant, then doesn't radiometric dating kind of fall apart?
There are 3 assumptions for radiometric dating. One is that you can figure out how many parent and daughter atoms there were in the rock or in the mineral to begin with. A second assumption is that Once the rock or mineral formed, it hasn't been altered since then. And the third assumption is that you have constant decay rates. And the scientific community recognizes that sometimes those assumptions work and sometimes they don't. And so they have ways of kind of determining when they do and when they don't. And so when we run samples, you know, probably 10 or 20% of the time, we find that those assumptions don't work very well. But 80, 90% of the time, they seem to pretty well. So that's the kind of things we're looking at that are very important to ask questions about. So yeah, good. Okay, I'm all finished.
Yes. Thank you very much. I really appreciate it. I really enjoy and a lot of to learn. I take a lot of picture and hopefully I will be able to check out all those website link. Okay. Well, I just wanted to check it out with you guys. So Dr. Clausen actually, so he will have very early flight tomorrow morning actually, and 6 o'clock in the morning, and so he has to go to Atlanta, so I'm pretty sure he will not be able to have too much sleep tonight. So, but we do have a one actual presentation from this evening. So I just talked with my leaders, quicker talk, so. Do you mind if we skip the supper? We'll move a little bit. Of course, we will give you time to stretch and okay. So then we don't need it to hey, after 4:50 or 5:20, we have give you another hour break. Maybe we just give a little break and we can come back together and let's just invite Dr. Clausen to have his last presentation. How is that? Is that good with you? Okay, that's good. Because then we can at least give him a little bit time to a little bit rest before actually. So he needed to. Otherwise, we will hold him for a long time. But thank you very much. So and I think that will help. Yes.